Hi, in this video we will introduce three notions: submatrix, ij minor, and ij cofactor. Later we will see that we will use these notions, well specifically ij cofactor, to define the or compute the determinant of n by n matrices. Okay, so let's dive into this definition. Well, we define all these things for square matrices. So let A be an n by n matrix. So it is a square matrix. Then ij submatrix of A. So the way we denote this thing is denoted by Aij. Well, remember that the ij entry of the matrix A we denoted by lowercase aij. The submatrix Aij we denoted by capital Aij. What is this? Is the n minus 1 by n minus 1 matrix. So it's a matrix which has one less row and one less column than a matrix A, obtained by, so what we do, we delete ith row and jth column of A. So remember, always the first index is row, the second one is column. So we delete the ith row, the first index row, and then second index column of A, and that gives you an n minus 1 by n minus 1 matrix. We then that's called the submatrix, ij submatrix. How about ij minor? So ij minor of A. So this is the determinant of submatrix Aij. So the submatrix you find by deleting row I, column j. Find the determinant of that, that's ij minor. And ij cofactor of A is, well, it is the minor, or ij minor of that, so determinant of Aij, but you multiply it by negative 1 to the power. So you see these two indices here, I and j. You add them, you put in the power of negative 1 and multiply to the minor. That will be the cofactor of the matrix A. Okay, let's do some examples and you'll see in practice what does these guys mean. Okay, here, so matrix is given and we are trying to find its some submatrices, I minors and cofactors. Okay, so A11. So what is A11? It is submatrix. How do we get it? Well, by deleting, so let me just write what is A. So A11, you get it by the first index, choose the row 1, you delete that. The second index, you choose that column, the first column, you delete that. This will give you a 2 by 2 matrix. And that is A11, the submatrix A11. Then a 1 minor of A is equal to determinant of A11. But A11 is a 2 by 2 matrix, so we can find its determinant easily. Diagonal entries minus of diagonal entries. and that gives us, well, negative 1. How about one cofactor? Well, cofactor is the same thing as the minor, but you multiply it by a negative 1 to the power. You see these two indices here. You add them and then multiply the minor by that. So it will be negative 1 to the power 2 times the matrix here. The minor here is negative 1. So this will be negative 1 to the power 2 is just 1 itself times negative 1. This is the cofactor is negative 1. How about A23? Okay, A23, you take the matrix A, you delete the second row and the third column here. This is going to be 1, 2, 2, 0. This is a 2 by 2 matrix, and that's the submatrix A23. While 2, 3 minor of A is determinant of that submatrix A23, which is again a 2 by 2 matrix, and in this case, diagonal entries minus off diagonal entries. You multiply diagonal minus off diagonal. So this will be 0 minus 4. Okay, so we have a negative 4. That's a 2, 3 minor. How about 2, 3 cofactor of A? So this is the 2, 3 minor, but you multiply it by negative 1 to the power. These two numbers, you add them, 2 plus 3, and negative 1 to the power 5 times the minor, which is this guy. So negative 1 to the power 5, or negative 1 to the power any odd number, is negative 1, and multiply it by negative 4, you get 4. Okay? And the last one here is that we have the matrix A, and we are looking for submatrix 3, 1. So we have this matrix itself, and then we delete row 3, column 1. This will give you a 2 by 2 matrix, and that is the submatrix 3, 1. Then 3, 1 minor is nothing but determinant of submatrix A3, 1, and this is determinant of 2, 3, negative 1, 0, which is 2 times 0 minus 3 times negative 1. This gives us 3. 0 minus negative 3 is just number 3. Okay, so how about 3, 1 cofactor of A? So this is the minor, then multiply it by negative 1 to the power sums of these two, sum of 3 and 1. This is negative 1 to the power 4 times 1 minor here. This is 3. And negative 1 to the power even numbers is plus 1 to the power times 3. This gives you 3. Well, there are two remarks here. First thing is that remember when we will, so remark 1, while computing the determinant of 3 by 3 matrix, so recall that in computing the determinant of 3 by 3 matrices, what we did was very simple in terms of the cofactors and factors. So we had the first entry times, remember we deleted row 1, column 1, and then we find the determinant of that. So row 1, column 1 is A11, and then we had determinant of this guy, multiply. And remember, I always said put plus sign. That is -1 actually to the power 1 plus 1, which is plus. So determinant of a 3 by 3 matrix. Then we subtracted. Well, that I will put it inside, and you will see that this was A12 times negative determinant of A12. Delete row 1, column 2. And then the third one was A13 determinant of A13. Well, this negative sign comes from -1 to the power 1 plus 2, and the plus 1 at the end is a -1 to the power 1 plus 3. And as you can see, we have what? A11 times cofactor times, 1 cofactor, then plus A12 times 1 2 cofactor, and A13 times 1 3 cofactor. So this is something that we will get back to it very soon for the general matrices, but for 3 by 3 matrices, this is what we had. And the second remark before our last example is that, well, the sign, the term -1 to the power I plus j in the cofactor. The formula for cofactor, remember, is -1 to the power I plus j times minor ij. But what is this -1 to the power I plus j? Well, we know that -1 to the power odd number, so I plus j, if it is odd, then we have -1 to the power odd 1, which is negative. And if I plus j is, is better, is an even number, then it is -1 to the power even number is always 1. Well, sometimes instead of doing that, so if you go one by one, so for entry 1 1, you always get plus sign. -1 to the power 1 plus 1 is -1 to the power 2, which is plus. Then the second one is minus, then plus, then sign minus, and this goes on. You pass to next row or column, you alternate, you change the sign. This is an easy way of considering that sign in the cofactor thing. That, well, starting from top left entry, you have plus, and then alternate everything and you get the sign for the cofactor. For example, in the above example here, you see this is plus, this is minus, this is plus, and that's why you see that this guy is plus. Or for this one here, this is plus, minus, plus, and then this is minus, yes? So that's why you see that in the cofactor, we have this -1 to the power 5, which is negative sign. And for the first one, this is plus, yes, this is where this -1 to the power 2 comes in. Okay. This was these three notions, and you have to know those ones, and you have to be able to work. We later do more work with this ij cofactors in particular.